Hi, I'm Dr. Fontes. I'm an assistant professor here at Westmont, and my research is about numerical modeling on multi-phase flow. Imagine that you wanted to understand a little bit of the physics in rocket jets descending on the moon. We don't have all the experiments or materials to do that kind of research here, but numerically we can approximate that kind of problem and have an interesting analysis of the problem and inform future missions of what can be done to mitigate the effects of erosion, for instance.
So we work on thinking about how engineering design can be improved. We create strategies and methods that help us to make engineering design processes more efficient and effective. One of the things I'm excited about is that all of this gets used immediately in our design classes. So as an example, we did some work last summer on how AI can enhance the engineering design process, and the seniors in the capstone design class are using that work right now.
Well, broadly speaking, I would say that my research is using engineering principles to study human biomechanics and neural control. So that more particularly takes the form of looking at how people balance and move. And there's a lot of application in that line of research to clinical populations.
We work with the Air Force and the Department of Energy. We're starting to work with a company called Mission Darkness. And they're all doing these problems that are really hard because that's what engineers do, is solve really hard problems. It's really fun because if you can make a difference there, then you're helping across the board in lots of different avenues, helping people just do whatever it is that they're working on with more innovation infused into the process.
My research focuses on additive manufacturing and prototyping. In past years, we've worked on new methods of additive manufacturing, specifically a new type of 3D printer. In current years, we're working on examining the material properties of 3D printed parts based on the printing parameters. We're trying to mathematically constrain the properties resulting from those 3D printing parameters sufficiently that we can actually take the data and plug it directly into FEA software to create simulations of the 3D printed part without having to detail every single filament ley line of the part. My hope is that this gives the students experience with the printers and experience with the design considerations that have to go into making a 3D printed part, and whether or not that 3D printed part can actually be used for their application.
Part of what we do as well is take biblical principles and try to use those to help us think well about the way that we do our design processes, because God is the great creator and obviously has tons and tons of innovation infused in all of the things that he has done and continues to do. We try to sort of data mine that a little bit and see if it can help us come up with good ideas as well.
So one of the other projects that I have is with Mr. Allison, looking at 3D printing sockets for amputees in developing countries. And in particular, I'm involved with an organization that does some 1 week service trips around the world, and we are pretty confident that we could deliver a lot more prostheses if we could use 3D printing. And so that's one line of research, is sort of in the rehabilitation clinical population side. And then the other side, which you see, there's a car seat and some aluminum surrounding the car seat and a seat belt and an airbag. One of the other types of biomechanics research that I do is related to injury biomechanics and looking at safety features in cars and how they function with the individual. So I worked with some students looking at how some of the seatbelt pretensioners function when you're leaning forward and out of position. And I'm also working with some students on some airbag related research as well.
So the last one is about spray formation related to the sneeze process. When you sneeze, how much droplets you have formed that could affect and transmit virus to other people.